Right, example 14. Dramatic music. That looks hard, doesn't it? Again, what I really like about this subject, because it looks hard, once you've got the method, it's really easy. Okay. Prove that 1 over root 1 minus x squared dx. So purely in terms of algebra, but prove you get this difficult looking trigonometric result. Not just sine, but arc sine, the inverse sine of x. Okay. Prove that. They haven't told you how to do it either. Well, bear in mind this is the substitution unit. That is your method. But what if you get that in the exam? Are you going to remember that substitution is your method? Exactly, yeah. You just got to know the substitution method is what you need to do. So where do you begin? What substitution do you make? Okay, I'll tell you what, you use this answer here as a hint for you. You're not going to use arc sine because that's way too difficult, but you can use the opposite of that, which is sine. You can make a substitution. Let me tell you what the substitution is. X equals sine. Now, we've been using u, okay, but generally speaking, when you make a trigonometric substitution, theta is the one to use, okay? Theta, Greek letters for when you've got trigonometry. Do you ever think about why we have that as a substitution? Maybe you pause the video and you just work through it and see what happens. Did you do it? Okay. Right, let's have a look, okay? So, before we substitute in, let's differentiate this. So dx d theta is equal to cos theta, and then dx is going to be equal to cos theta d theta. At the moment, it doesn't look like it's going anywhere, does it? Because last time we had a nice situation with things cancelling. At the moment, it doesn't look like that. You're not going to see it until you actually substitute it all in. So let's see what's going to happen. So 1 over square root of 1 minus x squared, which is going to be sine squared theta. And then the dx, we write that as there we are. Let's do it again. dx we can write as cos theta d theta. Okay, just putting that in there, okay? Now, what's going to happen? I'm hoping a lot of you are picking up on this, okay? Because as you know, cos squared theta is 1 minus sine squared theta. Okay, so in the square root there, you're going to write that as square root of cos squared theta. Okay, you can see these two are exactly the same. And that means on the denominator, you just got cos theta, which is the same as 1 minus sine squared theta. So the denominator is just going to be cosine theta. But wait a minute, what's on the numerator? It's cos theta, d theta. How does that simplify? Amazing, look at that, look at that, amazing. Something that looks really hard and it becomes so simple. The integral of 1, ladies and gentlemen, the integral of 1. You're never going to find an easier integral than that, okay? Even the integral of e to the x is not as easy as that, okay? That's just going to be theta, isn't it? Plus c, don't forget the plus c in our enthusiasm, okay? So theta plus c, that is it. Now, what do we then do with it? We've got to replace theta with x, okay? So rearrange this, make theta the subject, that is arc sine x. Fantastic, okay? We have got arc sine x plus c as our answer. That is the genius of maths, okay? That's a beautiful solution, okay? If you're up for it, I'll show you an alternative approach that does not use integration, if you're up for it.